Alrighty. So, what are we doing today? We're going to practice some FRQs that are polar, right? So, you go get it. You have Firefox, right? Go get it. 2014 BC2. Go get it. Go get it. You can do this on your own. I know you can. You're good at this. apcentral.collegeboard.com. 2014, last year, BC2.
Well, I have it on.
Go to exams, go to exam information, click it.
I have it printed.
Go to STEM, go to BC, click it. Scroll down to 2014, click free response questions. Scroll down to number 2.
There.
Yes, you did it. I knew you could. Did you do it?
Yeah. I have it printed.
And you have it printed. Oh, that's bonus one. So, here we go. The graphs of the polar curves r equals 3 and r equals 3 minus 2 sine 2 theta are shown in the figure above. By the way, they don't have the graphic for you because BC2 is the calculator active section, so you might have the graphic yourself. Are shown in the figure above for theta between 0 and pi. Let R be the shaded region that is inside the graph of r equals 3, but outside the graph of 3 minus 2 sine 2 theta. Find the area of the region R that's shaded. Okay, so which one of these is r equals 3? Which one of them? The circle, because if r is always 3, and theta can be anything, the radius is always 3, it's not changing, it's got to be a circle. And, oh goody, thank you. Alrighty.
You have it covered?
I hate this freaking stuff. I got stuff to do.
What did you get?
Yeah, I got lease, 9th period. I'm going to be lease. Yeah. Where the hell, see, what room is this? Yeah, what room is this? Subject? Oh, 217A? Okay. All right, anyhow. So, how do you get the area of the region? Well, first of all, is this part in the second quadrant easy? Because what is it? It's in 1/4 of the circle. Now, the circle has radius 3, yes? All right, so if you have radius 3, what's the whole area of the whole circle? Pi r squared. So the radius is 3, 9 pi. But you want only a quarter of it. So part of the answer is 9 pi over 4, right? That's done. Plus. Okay. This region here, which is the area enclosed by 3 minus 2 sine theta, 2 theta, from 0 to what? How many radians? Is it pi? 5 or 2. Now be careful. Sometimes you want to make sure that you're at the right place. If you plug in pi over 2, what's 2 times pi over 2? Pi. And then what's the sine of pi? 0. And so negative 2 times 0 is 0, or 2 times 0 is 0, from 3 is 3. Is that where you are? At 3? Make sure you're at the right place. Sometimes if this frequency is too huge, the period is too small, it may not be 0 to pi over 2, it may be 0 to pi over 4, maybe 0 to pi, maybe 0 to 2 pi. It depends on the frequency. Be careful. Okay? So how do you set up the integral for that area?
The bigger one minus the smaller.
No.
Oh, isn't it just in
No, it's just what's in the polar graph.
from 0
It's
to
just this
theta?
guy, right? All right, so it's going to be the R. It's going to be the 9 pi over 4. Why is it laggy? Stop that. R is, by the way, this is 2014 BC2.
How do you know what is R? This line right here? No, little
R,
this R right here. Is
that
this
R
line?
is the length of the vector depending on theta. Wherever theta is. So now it's 3, now it's 3, now it's not. Depends on when you plug in theta, what you get. Okay? So it's going to be the quarter of the circle in the second quadrant plus. Now, how do you set this up? Remember, we talked about this yesterday.
Wait, Mr. Garcia, I get that. I'm saying that this R represents this circle, right?
Yes, that piece.
And
Yeah.
this R
Is the circle part, because that's a circle, see it? Okay, so how do you set it up? The integral from 0 to pi over 2. Now, how do you set this up? 1/2 3 minus 2 sine 2 theta squared d theta. There you go. Perfect. All right, now, notice this is in the calculator active section. So what do you have to do? You write it down, what you're going to do, then do it. Don't tell nobody details. I press this button, I press that button. Nobody cares. And say what you get. Yes? Yeah. All right, so let's do it.
Why'd you do 1/3?
What did I do what? Because remember we talked about this yesterday. The area of a circular slice, we're slicing it up into little pieces of circles, right? Was 1/2 r squared theta. That's what it is. We're adding up circular slices, right? All right, so let's do it. So get a new document in case you're, no, new document. What are you doing? Go away. New document, damn it. Okay, give me a calculator page. Unless, of course, someone stole your calculator. Did I get everybody who's got a stolen calculator? Sarah, do you have yours? Yeah, okay, just checking. All righty, so let's do it. It's going to be 9 pi. Well, you know what? Wait, skip that. Let's do a rational.
What are they supposed to do for the AP?
They're going to have to replace it.
For the
Okay.
AP?
Okay, 9 pi. Where the hell is pi? Okay.
Um,
Okay, if you don't have an Inspire, I have a couple extras. So see me after class or after school or a free period or something like that, and we'll modify your rental agreement. Okay, if I gave you one, I can give you another one. If I didn't give you one, you got to get your own. If you lost one of mine, you got to go buy a new one. Did you read your rental agreement before you signed it? You got to buy a new one and give it to me because they're mine. They're not the school's. You give money to the school, I'll never see it. That doesn't satisfy your rental agreement. Careful. All right, so over what for? Okay, plus. All right, so it was 1/2. How about we do it this way? The integral. Where's it? 4. No, 3. From 0 to pi over 4.
Pi over 2.
Pi over 2? Pi over 2, yeah. Of the quantity, what the heck was it? 3 minus 2 sine 2 theta? This takes too long just to type it. That's all, minus 2 sine 2 theta. Where's theta? Down here. Come on, today. Okay, close the sign. Close what you're squaring. Square it with respect to theta. Oh God, we got to go over here again. Well, that's an exact answer, but they gave me a decimal here. What'd you get? Did you get this one? Did you do this one at all on your own? All right, how about a control enter? 9.708.
Wait, how did you get? Yeah,
How to get what? Okay. Which part? Which part? You didn't get the same answer, did you? You enter the right parentheses and the right squaring and all that stuff? And in radio mode, don't forget, you got to be in radio mode. Okay, so there's that quarter circle, and there's the piece of that, whatever that weird shape was, and you're done. Now, I don't know if they'd accept the exact answer here. If you're using a cast, they allow a cast. I think they like to see decimals here, so I don't know. It's 5 pi minus 6, or it's 9.708. What was it? 5 pi? 5 pi minus 6 is the exact answer. And the approximate answer is 9.708. Right, but be careful with this question. There's no reason why this question couldn't appear, where is it, on, say, part 2b. You could easily do this question on part 2b. What is required to do this question? They gave you, they're using reference angles. You don't need a calculator for this part. How do you do this without a calculator? How do you anti-differentiate this analytically? Run away and cry, and then you come back. You square everything, you FOIL it out. So you're going to get what? 9 minus 6 sine 2 theta plus 4 sine squared 2 theta?
Yeah.
The only difficult part here is the sine squared. How do you do the sine squared part? You use the trig identities I gave you. Yes? Oh, wait a minute.
That would be some serious
So-
amount of work.
Where's my moto?
You would need like a half an hour to do one problem.
Okay. Yeah, this one does take a while if you do it that way, but it can be done that way. So they might give you like a short version of that. Okay, so let's see. Remember your trig identities? Did you see this? I put this up last night. The Pythagorean trig identities, cosine squared plus sine squared is 1. 1 plus tan squared is secant squared. Cotan squared plus 1 is cosecant squared. The sine of the sum of two angles, the sine of the different two angles, the cosine of the sum of two angles, the cosine of the different two angles. By the way, this doesn't usually come up on the AP, but we use this to figure out the derivative of sine and the cosine, all that, way back in the beginning of the year, right? And if you combine these Pythagoreans with these, you get these. All right, so if you have to integrate sine squared, you do this. 1/2 minus 1/2 cosine 2 theta. If you have to integrate cosine squared, you'd use this. 1/2 plus 1/2 cosine 2 theta, right? So you could actually do this problem by hand without a calculator and get that exact answer by yourself. Okay, it's totally doable. And there's what? Other than that, there's u sub running around, right? The sine of 2 theta, that's a u sub, right? So this is eminently doable in part 2b. This could be a question 3, not a question 2, right? There are 2 free response questions with calculator, 1 and 2, right? Okay. All right, so let's go back to the question. And where was it? Where did I put it? Ugh, it's way over here. Okay. All right, what's part B? For the curve r equals 3 minus 2 sine 2 theta, find the value of dx d theta when theta is pi over 6. Well, remember that x equals r cosine theta, and r is stuff. So how do you get dx d theta? Differentiate r cosine theta, and then plug in pi over 6. Again, you don't need a calculator for any of this. Pi over 6 is a reference angle, right?
Wait, dx is the same as r?
No, x equals r cosine theta. Remember we talked about parametrizing a polar graph yesterday? So if you have r theta, but you need x, you do r cosine. If you need y, you do r sine, right? Okay, so let's do it. So here's part B. So part B says, all right, if we know that x is r cosine and r is 3 minus 2 sine 2 theta, just multiply by cosine, and plug in and do the derivative and plug in pi over 6. Now, this is a calculator active section, yes?
Yeah.
So all you got to do is say what x is, because nobody told you, and then do this on the calculator.
X equals r.
R times cosine theta, right? Okay, so look, state what you're doing, because they didn't give you this, right? They gave you r, but they didn't give you x.
Yeah.
Do it on the calculator. You could do this by hand if you want. Very easy to do this by hand if you want, but you have a calculator section here, right? All right, so you're going to plug that into your calculator. So how do you do that in the calculator?
You do the derivative at a point.
Derivative of a point. Okay, so menu, calculus, derivative at a point. There you go. What point? Dang it, really?
Pi over 6.
Okay, menu, calculus, derivative at a point. Why isn't it going down? There it goes. Okay, so pi over 6. All right, so where's pi? Pi over 6. And it's the first derivative, right? All right. So what goes there in here?
What you just wrote.
Just type it out, right? So it's r. Okay, what the heck is r? So r times cosine theta. So quantity, r is, again, 3 minus 2 sine 2 theta. Minus 2 sine 2 theta. And we're doing this with respect, well, now notice, if you do the menu derivative at a point, it's assuming a function in x.
So just write it.
If you do it with the template, you can fill in that you wanted theta on the bottom here.
Or can you just call it x?
Yeah, so just call it x? Yeah, okay, so 2x. And close the sign, close what you're multiplying cosine by, and multiply by cosine. and it's cosine theta. No, cosine x, cosine x. Well, it's actually easier to do it in x because you don't have to go through this menu over here. So da 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 da, and that's it, right? Now, if you did it by hand using reference angles and the product rule, you could differentiate this with product rule, and you plugged in your pi over 6, you would have gotten this. You could do this by hand. But if you want a decimal, you get negative 2.366-ish. Yep, that's right. Okay? So that's all you have to write. It's approximately negative 2 point, no, that's a negative. 2 point, what did I get? 366? You want to write it as an exact answer? There's no reason you can't, I guess. But you got to show that. If you write an exact answer, you got to show the product rule. You got to show plugging pi over 6. You got to show the reference angles. Yeah. That's a question 3. That's not a question 2. So in a question 2, do it on the calculator, give me a decimal, walk away. You're done.
Is there? It's 4 questions or 6 questions?
There's 2 free response questions with a calculator, and there's 4 without. Yeah. It used to be 3 and 3, but lately it's 2 and 4, because there's not a lot of calculus to write down. They want you to see if you can write down some calculus. That's part 2B, right? All right. Are you ready for part C? All right, part C. The distance between the 2 curves changes for theta varying from 0 to pi over 2. Find the rate at which the distance between the 2 curves is changing with respect to theta when theta is pi over 3. So what's the distance between, from 0 to pi over 2? From 0 to pi over 2, right? First quadrant. What's the distance between this and this?
The area between them.
Right, they're talking about the radial distance, right? The r distance, delta r. That's what they're talking about. All right, so it's 3 minus this guy. And then you want the rate of change to differentiate, right? And then plug in pi over 3, was it? Okay, is this terrible? No. All right, so boom. All right, so your, I don't know, your distance is the outer polar curve, which was 3, the circle, minus the inner polar curve, which was 3, minus 2 sine 2 theta. And remember, how do you subtract? Never, never do. So we're going to add a negative 3, and the positive 3 cancels, and we're going to add a 2 sine 2 theta. Do you really need a calculator for this? What's d theta? The rate of change of the distance with respect to theta. So the derivative of sine of stuff is cosine of stuff times the derivative of the stuff, which is 2 with respect to theta, and you got a 2, so 4. And plug in what, pi over 3? Did I mess up?
That's part D or part C?
This is part C we're at. Right? Do you need a calculator for this? No. Could you use a calculator instead? Yes. All right, so what is the rate of change of the derivative with respect to theta when theta is pi over 3, they want? So it's 4 cosine 2 pi over 3, isn't it?
Yeah.
Now pi over 3 is 60 degrees. 2 pi over 3 is 120 degrees. You're in the second quadrant. Second quadrant cosine is negative, but you're 120 degrees, 60 degrees from 180, so it's a 60 degree reference angle. What's the cosine of 60? Cosine of 60 is the x part. Notice I got rid of it. It's not here anymore. It's a half, but it's second quadrant. Negative a half times 4, negative 2. Now, you could have just done derivative at a point of that. Plug in that. You'll get that. You didn't have to show this for a part 2A, right? But could you? Yeah, sure. Why not? It's a free country. But you have to do this if it's a question 3 or 4, right? Is that okay? So you could do the derivative at a point on the calculator thing, right? So show what you're differentiating and then do it on the calculator. You'll still get the negative 2. You don't have to show this. You don't have to show this, right? Are we okay? Okay. All right, so that was part C of that question. So what's part D?
It's just
A particle is moving along the curve r equals 3 minus 2 sine 2 theta. So forget the circle part, just this wavy part, okay? So that d theta dt is 3 for all time t greater than or equal to 0. Find the value of dr dt when theta is pi over 6. Huh. Wait a minute, what?
Just take the derivative of that.
With respect to t, but we have everything with respect to theta.
Yeah, but
So what do?
you do the inverse D theta.
There's a chain rule here.
Yeah.
You see it? Okay. It's sort of like the parametric chain rule. So if you want dr dt Dang it. And don't they give you in the question d theta dt is a constant 3?
Yeah.
How do you get from d theta dt to dr dt? What's missing? How do I, dr d theta? Do you see this is like a parametric chain rule?
Yeah.
The d thetas to cancel? So they give you this part. This is a constant 3. You can figure out this part because you know r. And you're going to plug in, what is it, pi over 6? Okay. So this is going to be the derivative with respect to theta of your r, which was 3 minus 2 sine 2 theta, times 3, because this is a constant. Right? So you can put that in the calculator, do derivative at a point or whatever, but do you have to? What's the derivative? This is the RD theta right here.
So why
D theta dt was given. That's a constant 3 in the question. Look at the question. The d theta dt is a constant 3.
yeah.
That was a hint. To get the r dt from the r d theta, you're going to use d theta dt, right? Okay. So are we good? What's your
Why
question?
did you write d theta? Oh, 'cause it's
The r d theta is the derivative with respect to theta of r. Right? Okay, so what is that derivative? What's the derivative of 3? 0. What's the derivative of sine of stuff? So cosine of stuff times the derivative of the stuff is 2 times the other, negative 2, so negative 4. Times the 3, though, so negative 12. Okay, negative 12. And we're going to do this at pi over 6, wasn't it? So what do we want? The RDT, when theta is pi over 6, is plug in pi over 6. You get negative 12. The cosine, what's 2 times pi over 6? Pi over 3. What's the cosine of pi over 3? 1/2. So you get negative 6. Again, you could just plug this into your calculator derivative at a point, plug that in, you're going to get that. What?
If you were just taking the derivative, you get negative 4 on the outside.
Right, but then they multiply by the 3 they gave me. Right. Okay, so any problems? Now you could do it like it was a question 3, or you can plug it into your calculator like we did before, derivative at a point. All right, so was 2014 number 2 BC2 bad? No? Okay, we don't have a lot of time, but we could start. 2013 BC2. All right, so let's take a look at 2013 BC2. Question is, what? Okay, we don't have a lot of time, but we could at least start talking about 2013 BC2. You ready? All right, go find it. You got it ready? Oh my God, this is too easy. All right, so let's go back here and let's go down to 2013 BC2. They said to plug in pi over 3 in the question. I'm sorry, what? Pi over 6? Oh yeah, we plugged in pi over 6, but there was a 2 theta. We plugged into 2 theta, so 2 times pi over 6 is pi over 3. Okay, all right. So let's open this up. Come on, today. Why isn't it opening up? Oh, it's here. Okay. All right. So, all right. Look, this is almost the exact same question. The graphs of the polar curve r equals 3. Which one is r equals 3? Look at it. It's the circle of radius 3, center to the origin. And r is 4 minus 2 sine theta, as shown in the figure above. The curves intersect. They give you the points of intersection. All right, let S be the shaded region that's inside the circle and also inside this other polar graph here, which looks like a cardioid, right, with a dimple. Find the area of the S. Okay, so it's a cardioid with a dimple. Not a sharp cardioid, not an inner loop, limit sign. You forgot this stuff?
No, because it's a cardioid.
It's a cardioid. Okay, anyway. So, how do you get that? Well, what about this piece down here? You see this piece down here? Do you know that area below the x-axis? It's half of the circle with radius 3, so 1/2 of, which is 9 pi? 9 pi over 2? All right, so that part's 9 pi over 2. Then you want to go, wait, now, hang on. Oh, no, you don't, because, let's see, do I get ink layer here? No? Can I write on this? No? Okay. Well, do you see that this is pi over 6? this angle, and this is 5 pi over 6, this angle, right? So you have to take the sector. Oh. Damn it! What is that? Oh God! Don't do it.
There's a circle maker.
This circle maker. See right here. Okay. All right. So look. So this is at pi over 6. This, say, is at 5 pi over 6, right? And this is the x-axis, say. Okay. Yeah, you do better. All right. So this is your pi over 6. This is your 5 pi over 6. Right? So you want this area down here, right, is the area of a sector, right? So what's your delta theta here? 4 pi over 6 or 2 pi over 3? So remember, the area of a sector is this. So what you're going to do is you're going to take the area of the whole circle, which is 9 pi, minus the sector. That's going to give you this sector. Minus this sector. So this is 5 pi over 6 minus 1 pi over 6 is 4 pi over 6 is 2 pi over 3. So you got 1/2 of 3 squared times 2 pi over 3. So you get 3. You get 3 pi, don't you? So you have the whole circle is 9 pi minus 3 pi is what's left? The whole circle is 9 pi minus 3 pi. This is 6 pi.
Wait, can you go back to your original?
What? The question?
Because it's all inside the circle.
Right. So they're saying this piece that's based on the circle, up to here, from here to here. We figured out that's what was 6 pi?
But it's not all of that.
I know. It's this piece all the way up to this piece is all circular, right? So it took away the 3 pi from the 9 pi and it got 6 pi. Now how do you get this piece in here? In here. What do you do? Isn't it the integral from pi over 6 to what? 5 pi over 6, 1/2 of r squared. What was r this time? It was 4 minus 2 sine theta.
Why couldn't you do it the original what you just said?
Well, no, I'm doing 2 pieces. I'm doing the 6 pi plus that. And you should get something around 24.709.
Just work fast.
All right, so practice some more of these. The answers are on the website too.
If you don't know it,
All right, so we're done. This is our last screencast ever because Monday is going over the NCQ of the practice exam, which is restricted. Can't record that. And Tuesday you have a party in the morning at the district office. Or where are you guys on Tuesday morning? Where do you go? Is it DO?
Yeah.
Yeah? Okay.
Right. So the 3 pi we calculated was not actually the circle. We calculated the piece that was not going to be calculated.
Exactly. Right.
So you
Right, we took away the 3 pi from the 9 pi, that's the 6 pi.
you had to do it that way because
Because the rest is based on the cardioid.
yeah, but you couldn't do it the other way where we did like half of it and then the left.
You
so the
could,
cardioid
but
doesn't
you
hit that.
probably could, but that's a lot of work. Why?
Yeah.
Alrighty, that's it, YouTube. Enjoy your last screencast ever. Bye-bye. Have a nice summer. Good luck on Tuesday.